Howdy, team. Welcome to part 4 of our trees exploration, our first trees exploration. And in this video, we are going to talk about what it means to write a tree data structure in Java. So in Java, there is no tree interface. There is no implementation of a tree. You'll need to write your own. I add an asterisk here because if you look it up, you are going to find a class called default tree model that is in the java.swing package, which is in it's meant for GUI work. It is not intended to be used as a tree, and it comes with a pretty heavy price tag in terms of the size of your application, like how much memory it's going to take once it's compiled. Because if you are not otherwise using the Swing package, um, it it's probably better that you don't use this default tree model. It's not meant for that. So generally, if you want a tree data structure, you need to write it yourself. Lucky for us, though, that's not really hard to do. Creating a tree is very, very much like creating a linked list. So the tree is going to keep track of its root node. So the data structure itself keeps track of the root. The root is going to be just a node, and all nodes are going to have the same definition here. So the data type is called a node, and you have a pointer here to the left subtree, and you have a pointer to the right subtree. Both of these pointers, these references or addresses, they are pointing to other node objects or null if they don't have any children. So those would be pointing to null. The data, um, generally your data structures like this are going to be holding reference type. So the data is going to be um, pointing to something, a dog, a student, a car. Um, so the node class just has 3 pieces of data in it, left, right, and one that's called data. You could call it cargo, you could call it whatever you want. Um, so I mentioned before that you have a binary tree class that's going to store here items of type E or type T. This is a generic fictional class. We haven't actually written this class, and it doesn't exist in Java. So this is one that we would be writing, but we would write it generically so that we would be able to reuse it for lots of different types. So if we have a binary tree of type E, this means that our data or our cargo is going to be of type E. That means that a binary tree has one element in it. It's called root, and it is of type node, and it points to a node. So here you can see binary tree points to one node, and that is the root. The root then is able to point to its left and right subtrees. The data it's holding inside right now is a character called a star, or the asterisk character. Um, I did say that our tree could only hold reference types. So that means the type of this binary tree is capital C character. So it is the character wrapper class that turns a primitive type, like a character, into a reference type. So the data here is a reference to the asterisk character. Okay, so then the left points to another node here, which has its own left and right pointers. All of these pointers, these um, boxes that have arrows coming from them, those are addresses or references. So you can imagine that if we have a node class, the node class has in it, let's write it down. So the node class has a node of type E left. It has a node of type E right. And it has a type E data. In some of our other examples, we've called it cargo. The word data, you could use any word that you want. These are variables. You could call them all of them, anything that you want. But our node class is going to contain those three variables. And really, that's it. There are some behaviors that we'll talk about in coming in the next times we talk about trees. We're not going to talk about them today. Um, but there are some behaviors like you would want to insert an element in a tree. You'd want to search for an element in a tree. Um, So that is how you would use or create a binary tree in Java. You'll have to do it yourself. There isn't one built for you. Um, and that sums up trees in Java. I told you it'd be a short video. I will see you in the next one where we talk about binary search trees. And that will be the last video in the series. All right. Thanks, team. Bye.